Welcome back to my YouTube channel, and in this video we are going to be talking about function that is divided into two or more subranges. That is, we can have two or three functions instead of just one function that they are asking you to find for the Fourier series. So here we have the function here whereby f of x is equal to minus x from minus pi to 0 and 0 from 0 to pi. So now let us move on. Now what we know normally is that our Fourier series here f of x is that they want us to put it into the form a naught over n plus the summation of from n to 1 to infinity of a over n cos nx plus summation from n equals to 1 to infinity of bn sine nx. And that is what they want us to do. So we just have to find for the constant. Now our constant a naught is equal to, for a naught, our a naught is equal to 1 over pi is the integration from 0 to 2 pi of f of x dx, which is the normal formula. But now it is broken down into two different parts here. We have minus pi to 0 and we have 0 to pi. So therefore this will be equals to 1 over pi. We bring out a big bracket in this scenario. We bring out a big bracket and then we are going to have, let's put it this way. We have it as 1 over pi, a big bracket. Um, the first one, integral from minus pi to 0 of minus x dx. We have, we plus it with the integral from 0 to pi of 0 dx. So this is how we are going to break it down. And so we know that the 0 just cancels out itself. So we just have this as 1 over pi times the integral from minus pi to 0 of minus x dx. 0 cancels out. And therefore, we have this as 1 over pi. After integrating this, we are going to have minus x squared over 2 from minus pi to 0. So we just impute, we can bring 2 outside. We have equals to 1 over 2 pi, and then we are going to have minus x squared, that is 0 squared. Then we also have our minus here. Then we also have the minus here, which is here, and this minus pi, it is the minus pi into square, then we close it. So at the end of the day, this is going to be 1 over 2 pi, 0 cancels out, we have minus, and we have our pi square. So therefore, this is going to be, because pi here, we cancel one of the pi here, and therefore, an would be equal to pi minus pi over 2 as our answer for an. So now let us move on to one here, like let's move on to the quotient an. So now we have an is equal to 1 over pi times the integration from 0 to 2 pi of f of x cos nx dx as our formula. So therefore, if we just break it down, we're going to break it down into two pieces. And it will be 1 over pi, put our big bracket, the integration from 0, minus pi to 0, minus pi to 0 of minus x times cos nx dx. We also have our plus integration from 0 to pi of 0 dx. So that is for that of 0 dx. Because 0 just multiplies cos out and becomes 0. Therefore, the entire 0 is going to go out. Therefore, this is going to become 1 over pi times the integration of minus pi to 0 of minus x. The minus can just come outside, so we have minus outside here. We have x cos nx dx. And then we use integration by parts. we have our u is equals to x, and then our dv is equals to cos nx dx. We differentiate this, the u is equals to dx, and we integrate this, v is equals to sine nx over n. So if we use our integration by parts formula, this is going to become minus 1 over pi. We put our big brackets uv, that is x sine nx over n, from minus pi to 0. Then we are going to also have minus the integration from minus pi to 0 of v du, which is equals to sine nx, then we have dx, we have over n. So this 1 over n can just come outside, we have minus 1 over n here. So therefore, we will finish it. So now, if we put minus pi into here, we are going to get 0. If we put 0 into here, we are also going to get 0. So therefore, this here, we will cancel out, and we are going to have minus 1 over pi, minus 1 over pi into brackets minus 1 over n, the integration of sine nx dx from minus pi to 0. So if we move on with that, it's going to become minus times minus, we have 1 over n pi. Then we also have this one here, but that is what's minus times minus. So now if we integrate sine nx, we are going to get minus cos nx. So this is going to be minus cos nx over n, due to chain rule effect. So from minus pi to 0, this minus can come out here. This minus that is here can come out here, and therefore we let's simplify. We have minus 1 over n squared. This n also come out times pi. We have our cos nx from minus pi to 0, from minus pi to 0. So therefore, if we move on with this, we just repeat our values. We have minus 1 over n squared pi into brackets cos 0 minus cos n, cos into brackets minus n pi. But now cos here is an even function, so even if you have a negative value there, it's going to also be positive. So therefore, this will just become cos n pi at the end of the day, due to the fact that cos is an even function. So therefore, if we finalize this, this is going to give us a n here, which is equals to minus 1 over n pi. Then we have 1 minus, we know the formula here, which is here minus 1 raised power n, and we close it. So now here we cannot just assume that n is an even function or an odd function. So therefore, we have to calculate for when n is an even function and when n is an odd function. So we put when n is even. When n is even, like 2, 4, 6, 8, and so on, therefore we are going to have a of n. Let's just pick it. A of n will be equal to, we have minus 1 over n squared pi, which is the initial what is here, n squared pi into brackets 1 minus, now when n is even, minus 1 is going to become plus 1. So this will be 1 plus, minus 1 here will become plus 1, and therefore we have our minus here. Yes, we have our minus here, so we have minus plus 1, which is equals to 1, close brackets. And this here, minus 1 minus 1, 1 minus 1 is equal to 0. Therefore, this is going to give us 0. So also we are going to calculate for when n is odd. We have an would be equal to minus 1 over n squared pi into bracket minus. Now if n is odd, minus 1 is still going to become minus 1. So therefore the minus will cancel, multiply the minus, it will become plus 1. We close the bracket. So we finalize this, this is going to be equal to 2 over n squared pi. This is going to be equal to 2 over n squared pi. So now we have gotten our value for a n. We got our value for a n. So therefore we are going to have our value for a n here. We have a naught is equal to, we have our a n is equal to, we add our a naught, we add our a naught to be equals to pi. We have minus pi. Mm, we have our a naught to be equals to minus pi, and we add our a n to be equal to 2 over n squared pi. Take it from n squared to 2. We have minus pi. Take minus pi over 2. Yeah. We have minus pi over 2 here, and we have a n is 2 over n squared pi. Now 2 over n squared pi as n is odd. So that is it for our a of n. And now so we also have to find for the value of we also have to find for the value of bn there, which is our bn, and our bn is the integration from 0 to 2 pi of the integration f of x. Now we have f of x sine nx dx. So now our f of x here is divided into 2, so that means let's not forget our 1 over pi, which is outside here. So we have our 1 over pi. Then we open our big bracket. We have our integration. The first one is from minus pi to 0. Minus pi to 0 of minus x sine nx dx. Now we have plus integration from 0 to pi of 0 dx, because 0 is also going to multiply sine, which will just cancel out. So therefore this will become 1 over pi, 1 over pi, that is the integration of minus x sine nx dx. So the minus can just come outside here, and therefore we are going to have this as integration of x sine nx dx. So the next thing that we already know what to do is that we are going to use integration by parts. We have our u is equals to x. Our u is equals to x, and our dv is equals to sine nx. So we have our du is equals to dx, and our v is equals to minus cos nx over n. So now that we have add our value, we can just use integration by parts. We would have bn would be equals to, we have our 1 minus 1 over pi. Then our integration from minus pi to 0 will be equal to uv, which is equals to minus x cos nx over n from minus pi to 0. Then we have minus the integration from minus pi to 0 of cos nx dx, and the over n you can put it out as 1 over n over here. So now we have to do our continuation, which is here. We have to do our continuation. So now, doing our continuation here, we have Bn is equal to, we have minus 1 over pi. Now, using this, we have minus x cos nx over n. Now, we have from minus pi to 0. So if we impute these values here, we are going to get, if we impute the values there, we are going to get it as 0 cos n, that is 0 cos 0 over n, 0 cos 0 over n minus, we have this second one, which is our minus minus x, which is our, we have minus x, but x also is equal to minus pi. Minus pi, then we have cos minus n pi, which would cancel the n minus outside because it is a positive function. Minus n pi over n. So that is what the first one is going to look like before we now have the integral here of minus 1 over n. The integration from minus pi to 0 of cos nx is equal to sine nx over n from minus pi to 0. So this is what it is going to look like. Now 0 here cancels out. So this is minus 1 over pi. We have this as 0. Then we have minus multiplied by minus plus. We also have this minus here to become minus pi cos n pi over n minus, now this n can come outside, we have 1 over n squared. But if we impute these values, we have that sine 0 minus sine minus n pi. But sine is an odd function, therefore the negative comes outside. So therefore negative here will multiply this, so we have that plus, and this is 0, this is also equal to 0. So at the end of the day, we are just going to be having minus 1 over pi, our brackets of minus pi over n, cos n pi is known as minus 1 raised to power n over the n, and this here is equal to 0. So therefore this is just this. So pi can cancel pi here, minus multiplied by minus, and this will be equal to 1 over n for minus 1 raised to power n. Now, since as I said earlier, we are going to find for when n is even and when n is also odd. So when n is even, that is n is like 2, 4, 6, 8. So we have b of n is equals to 1 over n. When n is even, minus 1 will become plus 1. So therefore minus 1 times 1, which is going to cancel out. So this is what it's going to become. We have 1 over n. And then when n is odd, we have b of n is equal to, b of n is equal to minus 1 over n. If it's odd, this will stay minus 1. This will have, yeah, we do not have a minus 1 here. Minus 1 in the bracket, and this is going to become minus 1 over n. So therefore, we have gotten our values for a naught, a n, and our bn for both even and odd. Our a naught, how do we got it? We got our a naught, just to revise, by integrating just this value, because the 0 cancelled out there. So we just add our a naught from minus pi to 0. We have 1 over pi of minus x dx. Here we have that minus x dx. Um, Here, that is how we got it for our a naught. And when we finish it, we have our minus 1 over pi. The integration here gives us x squared over 2. So that when we put our 0, we add it as minus 1 over pi of, we have 0 minus, we have, this is for minus 0, minus pi to 0. We have minus pi all square over 2. Okay. But yeah, the 2 came outside, which is 1 over 2 pi. So at the end of the day, this is equal to pi square minus pi square over 2 pi. We have pi cancel pi, and this is equal to minus pi over 2, which was how we got our value for a naught. And also our an here, which is how we got our value for a naught, which is minus pi over 2. And also our an is we calculated it when an is even, we add it as 0. When an is odd, we add it as 2 over n squared pi. Then this when n is even, we have bn as 1 over n. When n is odd, bn is equals to minus 1 over n. So to express it in the major Fourier series form here, we just put our f of x is equal to an over 2, that is minus pi over 2. Then we do our over an over 2 minus pi over 2 over 2, that is minus pi over 4. And we have plus an here. So it will be, we can bring out 2 and pi here so that n can stay in. We have plus 2 over pi times the summation of, now n here cannot start from 1, so we are just going to indicate that this is going to be odd, right? It will be 1, 3, 5. So n will be equals to 1, 3, 5 dot 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 up to infinity of the remaining part, which is cos nx over n squared, which is the value of n squared that is here. We got out our 2 and our pi here, and we can, for the sign here, for the value of sign here, we are going to be having 2. The first one is going to be equals to here we have plus the summation from of n equals to 2 comma 4 comma 6, that is the even one, 2 4 6 going like that, of sine nx over n. Then we also have for the negative one, which is plus the summation from n equals to 1 comma 3 comma 5 up to infinity of, now this is minus 1 over n, so therefore this is negative sign here. Then we have sine nx over n. So therefore this here is our Fourier series. This is our Fourier series final answer for the question that we are being given over here. Thank you very much.